Hi, my name is Timo from Tdivo and I come to you with the fourth episode in this series of recycling plastic waste. So the purpose behind this series was to show the whole process behind recycling plastic, and that is actually a lot more complicated than most people think. Luckily, in this series we're going to show all the steps that need to be taken in order to recycle your plastic waste, and this way you can get a little more knowledge of the process. So the first step was collecting the waste. We did this from walking around the office and collected whatever we could find, then sorting and identifying our plastics, and then we had to determine a goal for it. Well, the goal we determined was to make a nice 3D print, for example this. And in order to do this, there are also a couple of steps that need to be taken. For example, choose a material. We had a lot of these spools lying around, so that's why we chose it, and also because it's a nice and tough material. So the first step was to actually shred this into smaller pieces, and we obtained some nice, what we call regrind. And then we have to make some 3D printing filament, which looks like this. And it's basically a plastic wire which feeds into the 3D printer, and it serves more or less like the cartridge for it. So in order to obtain some 3D printing filament, we need to extrude the regrind that we have. So how does extrusion work actually? As I explained in the previous video, we need to completely melt the material and then we are able to give it a new shape. In this case, we need to push it through a die opening, which gives the material the desired shape. In this case, a round opening, because we want some round filament wire. In order to do this, you would need obviously an extruder. You can have either a DIY extruder or an industrial scale extruder if you have it at home, or a lab scale extruder. But they all work based on the same principle, and that is with an extruder screw that is placed inside a barrel with heaters around it. So with the help of the heaters and the friction that is generated by the screw, the material completely melts. At the same time, the material is being conveyed forward and pressure is being generated. This pressure pushes the material through the nozzle, and that way you are able to achieve some nice quality filament. In order to do this, you need to know what material are you processing with. In our case, polystyrene, because these anti-spools, they are made out of polystyrene. For this, we need to find out what the melting point of the material is, because you want the material to become completely melted and completely liquid to be able to push it through the nozzle. So, based on this information, we can set our temperatures in the extruder, but there are also some other things to take into precaution. For example, does the material need to be dried? Most polymers, they absorb moisture. Luckily, in our case with polystyrene, that isn't the case, but otherwise we would have to incorporate a drying step in between before we can extrude the material, because that has a severe effect on the quality of the output. But there is some precaution that we need to take with polystyrene, and that is the fumes that are released with processing this material. So quite some polymers, they release some toxic fumes when they're being processed at these high temperatures. This is around 200 degrees. For that you would need proper ventilation, or in our case we have a fume hood. So what this does, it just extracts all the toxic fumes and makes sure I don't inhale it. It's good to take into account that this whole process is an experimental process. It's very unlikely that you'll be getting it right straight away. Just like with the 3D printer, you need to find the right settings before you can actually achieve a quality 3D print. In this case, we need to set the right temperature profile in order to obtain some nice quality filament. Also, we need to apply the right cooling, etc, etc. So, the main point of attention that we're looking out for quality 3D printing filament is the diameter tolerance, because we don't want the filament to jam the printer eventually. So once we've mastered the process, we got our settings right, we have to make sure there's no contamination in the regrind, because that might happen. Some dust might fall in, or some foreign particles that accidentally slipped in, or we didn't clean our parts before we shredded them. And all of this can decrease the quality of the filament that we're producing, and then eventually also decrease the quality of the 3D print. So if we take this into account, then there's also the degradation of the material. So polymers, let me quickly do a recap of the theory behind plastics and polymers. So a plastic, as you should call it, is a polymer, and it consists of polymer chains. So if you really look onto it on a molecular level, then this material consists of long chains, and they're all entangled into each other, and that builds up the entire material. But if the material degrades under the influence of heating it too much or shredding it and chopping it, you sort of break these chains. And if you break these chains, you also decrease the quality of the material. So this means if you keep on recycling it, you also slightly decrease the quality of the material. So this is really important to take into account, and this also means that you cannot recycle your material indefinitely. So in order to work against this, you can make use of certain additives or mix it with virgin material. Of course, this is an experimental process, so feel free to try anything you want. Also, one thing I would like to mention is that not all plastics can be recycled into 3D printing filament. So in the first video we had the whole table full of plastic waste that I collected from our office, but not all of those materials could have been recycled into 3D printing filament. And it's also good to know that not all materials are actually the same. So we chose for the polystyrene spools, but we could have also gone for polystyrene plates. They're the same material, but it's actually a lot weaker. Like this plate, you can easily crack it and destroy it. And this spool, it's super tough, but it's both polystyrene, but it's a different grade. So made by a different company, different supplier, and has slightly different properties. So this might seem like a lot of information, but at least you understand the process a little bit better, I hope so. And this is it for this video. The next video will be where we print with the spool that we now made in this video of polystyrene, and that way we complete the whole process of recycling. Thank you for watching. My name is Timo. See you next time.